Optimizing Kubernetes Autoscaling with KEDA, a complete guide. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. As modern applications become complex, it becomes crucial to ensure they can handle varying workloads efficiently. With its Horizontal Pod Autoscaler (HPA), Kubernetes has been the go-to solution for many organizations to scale applications based on CPU and memory usage. However, as demands evolve, so does the need for more sophisticated autoscaling capabilities, especially when custom metrics come into play. This is where Kubernetes Event-Driven Autoscaling (KEDA) shines. In this podcast, we'll explore the limitations of HPA, the advantages of KEDA, and how to get started with KEDA to scale your Kubernetes deployments effectively. Introduction: HPA limitations and the need for KEDA. The Horizontal Pod Autoscaler (HPA) is a powerful tool in Kubernetes, enabling automatic pod scaling based on CPU and memory metrics. However, in today's cloud-native world, where microservices and event-driven architectures are prevalent, relying solely on these metrics is often insufficient. Many modern applications require scaling based on custom metrics like message queue lengths, HTTP request counts, or cloud service metrics like AWS CloudWatch alarms. HPA's limitations become apparent when scaling based on these non-traditional metrics. Without native support for these metrics, implementing custom solutions becomes cumbersome and error-prone. This gap in HPA's capabilities led to the development of KEDA, a Kubernetes native solution that seamlessly integrates with external metric sources to trigger autoscaling. KEDA, a Kubernetes native solution for custom metric autoscaling. KEDA, Kubernetes Event-Driven Autoscaling, extends Kubernetes capabilities by enabling event-driven autoscaling based on custom metrics. It's designed to work alongside the existing HPA, allowing you to scale pods on CPU and memory and external metrics like message queues, databases, and cloud service metrics. KEDA introduces a new resource called Scaled Object, which defines how a Kubernetes deployment should scale based on specific metrics. These scaled objects can monitor various metric sources, and when a certain threshold is met, KEDA triggers the autoscaling process. This approach provides a more flexible and powerful autoscaling mechanism, allowing applications to scale dynamically based on real-world demands. Installing KEDA, step-by-step deployment instructions. Installing KEDA on your Kubernetes cluster is straightforward. Below are the steps to get KEDA up and running. Add the KEDA Helm repository. Helm repo add KEDAcore https://kedacore.github.io/charts. Helm repo update. Install KEDA using Helm. Helm install KEDA KEDAcore/KEDA namespace KEDA create namespace. Verify the installation. Check that KEDA components are running. Kubectl git pods in KED. Once installed, KEDA is ready to manage the auto-scaling of your Kubernetes deployments based on custom metrics. Configuring IAM roles for secure Kubernetes service accounts. Security is paramount when dealing with cloud-native applications. KEDA interacts with external services, such as AWS CloudWatch, which requires proper IAM role configuration. To securely integrate KEDA with AWS, you must configure IAM roles for your Kubernetes service accounts. Create an IAM role with required policies. Create an IAM role with the necessary permissions to access AWS services. Attach the role to your Kubernetes service account. Associate the IAM role with the service account. Use the following annotation on your Kubernetes service account. API version, v1. Kind, service account. Metadata. Name, KEDA service account. Annotations. x.amazonnas.com/role_arn AWS, IAM : account ID role/role name. 3. Deploy the service account. Apply the service account configuration to your cluster. Kubectl apply fserviceaccount.yaml. This setup ensures your KEDA instance has the necessary permissions to interact with AWS securely. Defining scaled objects, triggering auto-scaling with custom metrics. A scaled object in KEDA defines the source of the metric and the criteria for scaling your Kubernetes deployment. Below is an example of how to define a scaled object for autoscaling based on AWS CloudWatch metrics. API version, KEDA.sh/v1 alpha 1. Kind, scaled object. Metadata. Name, CloudWatch scaled object. Namespace, default. Spec, scale target ref. Kind, deployment. Name, my deployment. Min replica count, 1. Max replica count, 10. Triggers. Type, AWS CloudWatch. Metadata. Namespace, AWS/Lambda. Metric name, invocations. Target value, 100. Oz region, US West 2. This configuration tells KEDA to monitor AWS CloudWatch for Lambda invocation metrics and scale the deployment between 1 and 10 replicas based on the number of invocations. Example scaled object configuration, autoscaling with AWS CloudWatch. Let's explore a practical example of using KEDA with AWS CloudWatch. Suppose you have a microservice that processes tasks from an SQS queue. You want to scale the service based on the queue's length. IAM role configuration. Ensure the IAM role attached to KEDA has permission to access the SQS and CloudWatch services. Scaled object definition. Here's an example of scaled object for scaling based on SQS queue length. API version, KEDA.sh/v1 alpha 1. Kind, scaled object. Metadata. Name, SQSQ scaled object. Namespace, default. Spec, scale target ref. Kind, deployment. Name, SQS consumer. Min replica count, 1. Max replica count, 5. Triggers. Type, AWS CloudWatch. Metadata. Namespace, AWS/SQS. Metric name, approximate number of messages visible. Target value, 10. Oz region, US East 1. QURL, https://sqs.useast1.amazonoz.com/account id/qname. This setup will automatically scale the number of SQS consumer pods based on the visible messages in the SQS queue. Testing KEDA autoscaling, generating load and monitoring results. Testing the autoscaling functionality is essential to ensure your configuration works as expected. Follow these steps to simulate load and observe KEDA in action. Generate load. Push many messages to the SQS queue or simulate many Lambda invocations to trigger the scaling process. Monitor autoscaling. Use Kubernetes tools like Kubectl to monitor the scaling behavior. Kubectl Git pods W. Check CloudWatch metrics. Verify that the CloudWatch metrics align with the scaling behavior observed in Kubernetes. This testing phase will help you confirm that KEDA effectively manages your Kubernetes deployments based on custom metrics. Conclusion. KEDA is a powerful tool that extends Kubernetes autoscaling capabilities beyond CPU and memory. It allows you to scale deployments based on custom metrics from various sources. Integrating KEDA into your Kubernetes environment can achieve more responsive, efficient, and cost-effective scaling for cloud-native applications. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.